Hello, if you're watching this video, that means that you have completely finished your Unit 6 study guide on your own. And you are checking with this video just to check your answers. All right, so let's get started. So number one, how many friends did Caroline survey? So we see that she surveyed some of her friends about how many scarves they own. So each dot represents a person. So all we got to do is count the dots. So I know this is 5, 10, 15, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. All right, number two, describe the shape of the data distribution in the dot plot. Now this one isn't as obvious to me as some of the others we've looked at, so let's see if we can eliminate some of our answers. So at the bottom it says most of the data lies above 6 scarves owned. Well, that's not true because that's only 5, right? The data distribution is symmetric. We definitely know that's not right. So we either have to pick that it's skewed to the right or skewed to the left. So overall, if I drew above these dots, even though it's not completely consistent, my tail definitely trails off on the right. So we're going to say the data distribution is skewed to the right. That's the best answer. Number three, the box and whisker plot shows the distribution of quiz scores for 2 students for a semester. So we have Raul and Homer. So what conclusion can we make? Overall, Raul has better scores than Homer, and Raul is more consistent in his scores. Well, I agree that his scores are more consistent because his box is a lot more narrow, but overall, he does not make better scores than Homer. Homer's is over here in the higher range. So A is out. Overall, Raul had better scores. All right, we already know that's not true. Overall, Homer had better scores than Raul, and Raul was more consistent in his scores. I agree with that. This says Homer was more consistent, but his box and whisker plot is a lot more spread out than Raul's. So it's C. Which of the following statements is true about the box and whisker plot? 75% of the data is less than 90. So here's 25, 25, 25. I agree with number one or letter A. Let's make sure B, C, and D are incorrect. 50% of the data gathered is greater than 65. 50%, oh no, like almost 100%, right? 50% of the data gathered is greater than 90. Nope, that's 25%. 25%, not 50. 25% of the data gathered is greater than 70. Well, actually 75%. So D is incorrect. So A is the best answer. Calculate the range. So the overall range, that means the very smallest number, the minimum, subtracted from the maximum. So it looks like the maximum is 100, the minimum is 65, so a difference of 35 on number 5. Rico has 4 20-point projects for math. Rico's scores are on the projects are shown on the chart to the right. Which of the following is the mean and median? So since we're doing median anyway, we'll go ahead and put them in numerical order. So his lowest score was 11, then 14, then 17, then 18, right? So we want to know what's halfway between 14 and 17. So I'm going to add 14 plus 17, which is 31. I'm going to divide it by 2. So I know the median is 15.5. So I know either B is the best answer or D, not A and not C for the median. And then for the mean, we're going to add up these numbers. So let's see, that's 15, 19, 20, 2, 3, 4, 5, 6, 60, but we have to divide by 1, 2, 3, 4. So 4 will go into 60 15 times. So we have a median of 15.5 and a mean of 15. Number 7, Anita's data or displayed numerical data using a histogram as shown at the right. Explain why the mean and the median of Anita's data are the same. Well, this is a very symmetrical histogram, right? Which means this represents half of our data. So half of our data is 7 or 8, so it'd be 7.5. And then since this is symmetrical, it also means the median is going to match the mean. It says the mean and median are the same because the data is symmetrical. I agree. Not the same. Nope. Because the greatest fluency is in the center. Well, I mean, that is true, but that's not why they're the same. Because even if it was the opposite, if these are our highest bars on the outside and they were getting shorter and the smallest one was in the center, letter A would still be true. Okay, and the data is definitely not skewed. So A is the best answer. Number 7, 7 friends, or no, excuse me, number 8, I saw the word 7. 7 friends compared their quiz grades. The dot plot shows the friends' grades on the quiz. Explain which measure of variation would be the best. Well, we know if there is an outlier, which there is, we're not going to use the mean. Okay, we're also not going to use the range because the range would make, this outlier would make the range large. So 100 minus 40 is 50, right? If there wasn't this outlier and our lowest grade was 80, the difference here would only be 20. The range would only be 20. So if you throw out the mean, you got to throw out the range. So we're going to go with the median. If you have a set of data and you want to talk about the which measure of variation would be best, if there's an outlier, you're going to use the median. All right, Mrs. Kirby asked each student in her class to write their age in months on a sticky note. The students in the class brought their sticky notes to the front of the room and posted them on the whiteboard. Their ages were reported as follows. All right, we're going to find these things. So we got to put these numbers in order. Oh goodness, this takes a while, doesn't it? 130, is that the lowest number? Y'all have already done this. I hope. You better have. 131. Oh goodness. 138. 139. Are there two of those? 139, 139. That one and that one. All right, do we have a 140? Yes, we do. 140. We have a 141. We have two 142s. 142, 142. We have a 145, 145. And then we have a 146. And then we have two 150s. Oh, I thought I could get it all on the same line, but I'm not going to be able to. And 155. All right, when you copy down numbers, always go back and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, I like when there's an odd number. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. So we have one middle number, which is the median. So 141. We know our minimum is 130. We know our maximum is 150. Now for the lower quartile, we need the middle of the smaller numbers. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, so our lower quartile is 138. Our upper quartile is 146. That's it. All right. Do we need to make a box and whisker plot? Nope, we don't, but we could, couldn't we? All right, according to this box and whisker plot, this is a group of military veterans that meet annually. These are their years, ages and years. What is the median age of the group members? So it looks like it's right on 65. The line through the box is the median. What's the interquartile range? So we're going to subtract the lower quartile from the upper quartile. So the upper quartile is 70 minus 57, right? So 3, 13. The interquartile is 13. Interquartile range, I should say. All right, number 13. Skylar stated his question, how many total goals did Julie make combined in her last 5 soccer games? Is that a statistical question? So if there's an exact answer, only one answer, the answer is no. If there's a variation of answers, the answer is a statistical, right? So if I ask this question, how many total goals did Julie make combined in her last 5 soccer games? There is definitely only one answer. You could go back and pull the records and count. So it's definitely not statistical. So it's either C or D because there's only one possible response. I agree with that. Because another teammate scored the goals. That doesn't make any sense. So C is the correct response. Number 15, the histogram shows the scores on a homework assignment in Mr. Jacobs' class. Which of the following would be a statistical question that could have been asked to represent the data? All right, so we have homework assignment is the title of our histogram, frequency, and our scores. How many students are in Mr. Jacobs' class? That would be a definite answer, one answer, so that's out. What do you make on the homework assignments? What did you make on the homework assignments? So if he's asking a lot of different students, he could get a lot of different responses, right? If I went to one student, they might make a 70. If I went to another student, they may have made, if I'm asking a whole class. So I'm leaning toward this one, but I don't know if that's the best answer yet, okay? Because if I asked you, what did you make on a specific assignment? There would only be one response that you could give me, right? All right, so let's see what C says. Why do you think so many students scored below a 70 on the quiz? Why do you think? Well, someone's response would be words, and these are not words. So C did not create this histogram. What was the typical score on the homework assignment in Mr. Jacobs' class? So this is sounding like it's almost wanting the class average, which there only would be one response. So B, if you ask this question to a whole group of students, all the different students could give you different answers. It's not a yes or no answer, okay? So B is the best response. All right, let's look at number 16. All right, so basically they want us to pick which box and whisker plot goes with this data. So let's put these in order. We have 2 6s. We have an 8. We have a 10. We have a 12. We have 2 14s. And we have a 15. So we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we have 1, 2, 3, 4 smaller numbers, 4 larger numbers. So our medium is between 10 and 12, which is an 11. And then our lower quartile between 6 and 8, which is 7. Our upper quartile is 14. So that's what we're looking for. An 11 for our median. So I know D is out, right? The rest of them are still in. We're looking for our smallest number to be 6. They're all still in. This is showing our lower quartiles 8, which is not true. So these are both still in. Our upper quartile is 14, which is this one right here. And this is showing our upper quartiles 13. So B is out. So that is the best answer. Number 17, on a homework assignment, Jesse got the following scores. He told his mom that his homework mean is 90%. Below is Jesse's work on how he got the mean. So Jesse got, these are his scores. He got an 185, a 0, which wouldn't make sense to add a 0 here, an 80 and a 95. So he added all the numbers up together, right? So even though if I wrote plus 0, it wouldn't change the sum of my numbers. However, if that's a score he made, you still have to use that number when you calculate the mean. So he shouldn't have divided by 4. he should have divided by 1, 2, 3, 4, 5. So he definitely made an error. Show Jesse the correct way. So I would say, Jesse, you forgot to divide by 5 because 0 was a score. And then I would show what his true average is. So 5 goes into 36 7 times. And 5 goes into 10 twice. So he said he made a 90. Look what a big difference that 0 made. He actually made a 72, and I would say that. Does he have an outlier? Yeah, these are pretty good grades, right? Definitely an outlier. The outlier is 0, and I would say 0 is much smaller than the rest of the data. The 0 brought down his mean from a 90 to a 72. That would be my explanation. All right, guys, I hope you did well. So you're going to take your test this week. So good luck to you. And if you have any questions or need any help, please let me know. Everybody have a great day.